Hey guys, in this video I'll be showing you how to use molar ratios. Okay, so first thing is when to use a molar ratio. Alright. If your start amount and end amount have different formulas, you're going to need a molar ratio. And if you need a molar ratio, you must have a balanced chemical equation. Without a specific equation, you can't possibly know what the exact molar ratio is going to be. And lucky for you guys, equations are usually given to you. Okay, so next I have just some example problems. We're going to go through whether or not you need a molar ratio in these examples. So number one here, if we look at everything it gives us, how many moles of C6H12O6 are present in 706.89 grams C6H12O6? I get it, it's really easy to get overwhelmed by a question like this. But if we just focus in on our formulas right now, we'll figure out if we need a molar ratio. So if we look, we have the exact same formula for both. We're not going to need a molar ratio for this one, so no molar ratio. All right. What we would need, because we have different units of the same formula, is that conversion flow chart we'd get from grams to moles. That would be a molar mass. Number two, how many molecules of AgNO3 are there in 12 moles of CuNO3 too? If we look at the formulas, different formulas, okay, you need a molar ratio for this one, and you'd need a balanced chemical equation, right? So we're not actually going to do this one, but you would have to have a balanced chemical equation for this if you were to complete it. Okay, so that one we do need a molar ratio. We have different units here, so we'd also have to do some other conversions, but we would need that molar ratio at some point. And our last example here, how many grams of H2O are produced from 850 grams of C3H8? Okay, different formulas, right? We would need a molar ratio, so need a molar ratio for sure. Even though it's the same unit, they're both grams, we would need to use a molar ratio for this one, right? Doesn't matter that they're both grams here, we'd need a molar ratio. All right, so that's just when to use a molar ratio. So let's talk a little bit more about how to find a molar ratio. You need a balanced chemical equation. Like I said, usually given to you. If not, right, it would probably be a skeleton equation that you have to balance yourself, or you'd have to pull it from the problem. But most of the ones I'm going to give you right now, you have this already. Okay. Now, every single balanced chemical equation has a ton of molar ratios you can use. You can make them by just finding a reactant and finding a product, setting them equal to each other, and we would have to include that unit mole with each coefficient. All right, so I'm going to show you how to do that in this example. For this balanced chemical equation, I'm going to make a couple molar ratios. Okay, so first select a reactant and select a product. Okay, one from this side of the arrow, one from that side of the arrow. I'm going to set them equal to each other while adding my unit mole. 1 mole C3H8 equals 3 moles CO2. Perfectly good molar ratio. Okay, if I want to use a different reactant, so this time I'm going to use H2O, a different product. I can use the same reactant, 1 mole C3H8, and just set it equal now to this product. 4 moles H2O. Right? I can use a different reactant as well and set it equal to each of these. So if I wanted to use 5 moles O2, could set it equal to 3 moles of CO2, or I could set it equal to 4 moles of H2O. Okay. As you can see, it's really easy to make molar ratios. The tricky part is going to be when to use which one of these. All right, so next example, you're going to only use a molar ratio for the reactants and products you're working with. You don't need to make 4 like I just did. When you have a specific question for this, you only need 1 molar ratio. So let's look at how to find the ratio we need for this problem. Right. Always we identify our start and our end. So our start here is 10 grams of oxygen. Our end is going to be grams of H2O. When we make the molar ratio, we're just looking at our formulas. So I see that I'm gonna start with O2, that's this guy right here, and I'm going to end with H2O. So it just tells me what molar ratio I need to make. So I can use this molar ratio right here, 5 moles O2 equals 4 moles H2O. That is the one that I'm going to need. Okay. So let's look at this question overall as a whole. You see I already got my molar ratio that I know I'm going to need here, but this is a big conversion problem with a dimensional analysis chart, so let's go through those steps. All right, first thing, what is it asking us to find? How many grams of H2O? So that is going to be my end unit and my end formula. So I'm going to put that over here on my goal, grams H2O. All right, now my start, it's giving me 10 grams of O2 to start with, so I'm going to fill that in my start part of the chart, 10 grams O2. All right. I know that I will need a molar ratio because I have different formulas, but if we look at our molar ratio, the unit is different from our start and it's different from our end. So that is when our chart comes into play here, right? We will need to convert 2 moles first before we can use our molar ratio. So to get from grams to moles, we'll need a molar mass. So from the periodic table, we'll have to find the molar mass for grams of for O2, and we'll have to find the molar mass for H2O. All right, check out that other video if you have trouble with that. But all right, I have it done already here for us. For oxygen, 32 grams of oxygen equals 1 mole of oxygen. And once we switch this from oxygen to H2O, we'll need to get back to grams of H2O. So we need a molar mass to go from moles of H2O to grams of H2O. And that one, you guys might even have memorized at this point because we've done the molar mass of water a bunch of times. This many grams of H2O equals 1 mole H2O. All right, so I have all my conversion factors now. I have my molar ratio in there because I'm going to switch formulas. Now I just need to line everything up. So I look at my start. I have grams O2. I look for a conversion factor that has grams of O2. It's this one right here. And I'm going to line this up in my chart so that grams O2 cancels out and I have moles of O2 left. So because this is in the top, grams of O2, I need this half of my equation in the bottom. 32 grams O2. Use that side. Now the other side must go up top. 1 mole O2. And a little line there to separate. So I've used this conversion factor. Grams of O2 cancels out. I'm now in moles of O2, getting closer to my end unit here. And now I can switch my formula from O2 to the H2O that I need. I'll use my molar ratio to do that. I have moles of O2, so I'm going to put this part on the bottom so that cancels out. 5 moles O2, use that side. And I need to switch to H2O, so that goes up top, 4 moles H2O. Line to separate, use that side. Okay, moles of O2 cancels out. Now I'm in the formula that I need, H2O. But I'm still in moles here, I need to get to grams, so I use my last conversion factor I found, the molar mass, to get from moles back to grams. Moles H2O needs to be on the bottom so that it cancels out. 1 mole of H2O, and up top, the other side of my conversion factor, 18.016 grams H2O. Moles H2O cancels out. I have my end unit now, grams H2O. That is what I want to have. Now I can do all the math. Right? It's 10 times, I leave out the ones because it's not going to affect our answer, times 4 times 18.016. That will give me 720.640 up top. And everything in the bottom, 32 times 5. that gives me 160